Welcome everyone. Welcome to the new show. And Katerina, thank you for joining us. So this session is brought to you by Dempaflux, where we work. I'm currently working as a growth manager over there. And what we do is we provide on-demand services for modern electronics companies, and we help hardware engineers to solve their EMC challenges at any stage of hardware development. We are here for the session with Katerina, and some of you might know. I would like to give a quick intro about Katerina. She is a distinguished senior antenna design engineer, and that's our second session with Katerina. So thank you, Katerina, joining for us. And she's also famous because of her LinkedIn post, and she has a quite diverse background when it comes to IoT products and also using and simplifying complex RF concepts. And with this, we can move forward and we can have our session, Katerina. So I will share my
Yes.
slides and you let me know if this is visible. And now, without wasting time, we can definitely start. So I think
Yes,
this is the one.
visible start. Yeah. So the content that we will talk about today, I will first start a bit introduction about that. What kind of RF challenges do we even have in IoT devices? Then maybe talk a bit about what kind of things we want to consider when we plan our device, IoT device. Maybe what we need to kind of think a bit more about. What usually people forget about. Then the most like hands-on part is I will go through 4 case studies, different IoT devices. I try to pick different like devices in different areas, right? Because IoT is very, very wide term. And so I try to pick kind of from different sides of that. And then in the end, just several practical strategies, what to one more time, maybe you will already have idea after all our this topics, and then we can just kind of repeat. So yeah, we can continue, Rahul, with the next slides with key challenges. So miniaturizations, I think you all know that like now modern technology and so is always we are obsessed with getting things as small as possible. We don't want to carry big things. We don't want to see like a big kind of like devices in our houses. And we want to kind of make them as small as possible. But with that comes very big challenge in performance, because wireless devices, they really depend on the size for antenna part. It's really important. We will talk about that a bit more on the examples. But this is like one of the key challenges, I would say. Then, of course, antenna integration, it kind of comes from the first one as well. But where do we put antenna in this compact device? What technology do we use? Because like what antenna? Do we have external antenna? Do we have internal antenna? Like how do we get together this compact device, right? So that antenna integration challenge. Then we have like different multipath interference in our environment, especially when we're talking about some industrial IoT, when we have a lot of metal around, or some like really harsh challenging environments like underwater, underground. We really need to think about like the environment and interference. And then in the end, when we already have our device, depends on the field that we use, intended to use the device, we need to think about what certification do we need to get, what regulations do we need to consider, and so on. Let's move to the next one. And things to consider, just a bit of like kind of like top layer. So in antenna consideration, we need to think about, do we want to have like embedded antenna? Do we have some PCB antenna, or do we have external antenna? Can we even afford that? Because in many cases, we maybe want to have like very small device where we just cannot afford to have external antennas and so on. So we really need to think about that before we start like designing anything, because that's very like very different approaches from antenna point of view, from like wireless part of the device point of view. Then we need to think about the size. Do we really need to have this small size, or we can maybe compromise a bit and get a bit more performance if we get a bit bigger size? The ground plane, and that kind of comes from the device size. So how big PCB we can get, how big ground plane we can afford to put our antenna on, and if we can, if we can maybe trade off a bit to get more performance. Then we need to think about what kind of connectivity we want to have in our device. And that's, do we need to have like cellular? If we want to have cellular, then we need to think about like what bands, what network we should support. If we want to have short range wireless, like Wi-Fi, Zigbee, like LoRa, and so on. So this decision should come very, very early on. It shouldn't be done when you already have some concept of the device, like maybe nicely done by mechanical engineer in some CAD software, because if like the choice of connectivity very like fundamental for the device, right? And it will affect a lot of implementation of the device, how things should be implemented. And then if we want to include matching network, and then we need to think about like, okay, if we include a matching network, then maybe we need to some place for this matching network. Then we need also to tune this matching network in the lab. Do we have this? Do we have this opportunity? Do we have kind of this capacity to do that? So that's just some. Of course, there are many more things to consider, but this is something that's like very important. And in my work, I usually like a lot of things I see that people maybe forget about thinking about that. So let's move forward to case studies, if I remember. Yes. So first case study is a smart light bulb, and so first, of course, many people, when you tell like something like IoT device, and many people think about smart home. So I was thinking this is good first example to have something from smart home. So smart light bulb. We really kind of want to kind of have our house more like maybe modern, and we have a lot of integrations in our houses. So that's something that we kind of maybe a lot of us have now at home. So next slide, please. And I would before we start, I would like see you can see the CT scan of a light smart light bulb. And please, Rahul, maybe can create a poll that I just want to see if people can maybe catch this. Where do you think the most optimal location for the antenna in this light bulb? So on the top, you can see this kind of area is glass, right? In the middle is PCB. Then in the top is our like socket where we would screw the light bulb. And some maybe people who more comfortable with antenna design, they might already see some hints in this CT scan. So maybe for them it will be much easier to guess. But yeah, so okay, I guess it's been already several.
Yeah. My question to you will be: how many percentage do you think will make it right?
I hope for at least 50%.
Okay. I'm curious then. I would love to see how many will win.
Yeah. Okay. So it's been 1 minute now for a quiz, and let's see. So the right answer is location A, and even I guess the people who maybe a bit more familiar with antenna design, they even can already see that there is actually antenna PCB there and trace for antenna, right? But so let's think about like what kind what kind of like challenges do we have in this design? So first of all, it's small, right? We cannot afford to have like, huge light bulbs. We want to have like small that it fits in, or our lamps or something, and we are restricted by this size. Then of course we have some interference from different other like maybe standards or wireless connections that we have. We have Wi-Fi connection at home, and we maybe have some other smart system in home that's like interfere with this light bulb. And then we have also the environment of the antenna. So if you can imagine, like you can see here, so all the